Hello everybody, hello calculus learners. Today we're going to talk about how to find the slope of a curve at any point using tangent lines, and also we're going to talk about how to figure out derivative of a function at the particular point using the limit approach. Okay, so until now you may have only thought about slopes of lines, but any curve can have a slope at a given point. Okay, and then this notion sits right in the heart of differential calculus. So since we're learning about calculus, we can separate it into two parts. The first one is differential calculus, the other one is integral calculus, okay? The integral calculus is, differential calculus is mainly about the derivative differentiation, okay? So today we're going to make an introduction to this concept, differentiation, finding the derivative of a function, talking about whether a function is differentiable or not, okay? So the slope of a curve at some point, is going to be the slope of the tangent line at that point. So in this case, you can see these lines in blue, okay? So these lines are tangent lines because they're touching the curve at exactly one single point, okay? So basically finding the slope of this curve at this point, it's going to be same as finding the slope of this tangent line at that particular point, okay? This is very simple. All right, so now the very important question may come to your mind about how to find the slope of tangent line at a given point. Okay, so the big insight here, and before that I would like to talk about, since I drew this tangent lines, and this is going to be the slope of the tangent line. So slope of the curve right here, it's going to be equal to the slope of the tangent line, but notice that right here we have horizontal tangent lines. So what does that mean? So basically horizontal, in this case, the slope is going to be 0. So the slope of the tangent line is going to be 0. Automatically, the slope of the curve at these points are going to be 0, which means at the minimum or the maximum of this function of this curve, slope is going to be equal to 0. All right. So now, the question that we were talking about is how to figure out the slope of tangent line. How do we do that? Okay, I'm going to show you in a very concise way. All right, so let's say I do have this curve, okay? Okay, so in this case, we know how to figure out this, slope of a line with given 2 points. For example, we have this point, okay, and then we have this point. So basically when you connect these 2 points, we're going to end up with a secant line, okay? And also finding the slope of the secant line is going to be very simple because slope is going to be equal to and delta y over delta x. So in this case, delta y represents the total change in the y variable, y values, and delta x is going to represent the total change in x values, okay? So it's very simple. And let's say this point is x1, okay? And then this is the point. Let's call it x1 plus h. Why would I call it x1 plus h? Because the distance between these 2 points is h. Okay? So basically, the big insight here is that as h gets smaller, the slope of the secant line gets closer and closer to the slope of the tangent line that we're trying to find out. Okay, so basically, mathematically, let's try to figure out this. Okay, slope of this secant line. So slope is going to be equal to delta y over delta x, or f of x plus 1, f of x1 plus h minus f of x1 over x1 plus h minus x1. So this is going to be our slope, okay? So now let's try to simplify it, okay? Let's try to simplify it. So the m is going to be equal to, okay, f of x1 plus h minus f of x1 over, so these two x1s are going to cancel each other out, and I'm going to be left with only with h, okay, in the denominator. So the closer, so what I have been trying to tell you is that the closer I try to move x1 plus h to x1, the more accurate the more accurate we get the slope of tangent line. So once we take the limit of this expression, so once I take the limit of this expression as h approaches 0, because we want h to approach 0. We want h very, very small, infinitely small number, so that we can get the accurate slope of tangent line. So limit as h approaches 0, f of x1 plus h minus f of x1 over h is going to give us the slope of the tangent line. Okay, it's going to give us a slope of the tangent line. So we want this distance between these 2 points very like infinitely small, okay, very small, so that we can get the slope of the tangent line. Okay, and once you take the limit of this expression, this slope value, slope expression, as h approaches 0, we're going to get the slope of the tangent line. So I would like to recap what I have been talking so far. Okay, I would like to erase the board. So far we've learned that the slope of a curve at any given point is going to be equal to the slope of the tangent line. Okay, the slope of the curve at any point is going to be equal to the slope of the tangent line at that particular point. How about the derivative of a function? Okay, because in derivative we are interested in the rate of change, which is the slope. So that's why I can draw this conclusion that the derivative of a function at any point, at any particular point, is going to be equal to the slope of the curve at that point, which is equal to the slope of the tangent line at that point. Okay, so let's move on to the next slide. Okay, in the next slide, let me try to make this bigger. Here we go. So it says derivative of a function, and analytically the definition of a derivative of f at x, limit of the difference coefficient, which is the thing that we are talking about. We talked about actually. Okay, and graphically, the derivative of a function at a point P is the slope of a tangent line to the graph of f at point P. Okay, and numerically, the derivative at a point is the limit of slopes of the secant lines or the limit of the difference coefficient. So we've talked about this. Okay, so we are finding the derivative of a function using the limit approach as an introduction. Okay, so let's move on to the next slide. So in the next slides, we're going to solve some problems. It says for f of x equals negative 5x plus 4, use the definition of derivative to find. So what was the definition of the derivative? Limit as h approaches 0, f of x plus h minus f of x over h. It's going to give us the derivative, first derivative. Okay, so let's try to figure out. Let me make this a little bit bigger. So, all right, let's find the first derivative of this function using the limit approach, and we're going to evaluate that derivative at x equals 2. So, all right, so limit as h approaches 0. So basically for x, I'm going to replace it with x plus h. So we're going to get negative 5 parentheses x plus h plus 4 minus the f of x itself. So minus negative 5x plus 4 over h. Of course, we have to simplify this expression algebraically. So limit, I'm going to do it over here. So limit h approaches 0, negative 5x minus 5h plus 4 plus 5x and minus 4 over h. So in this case, we have negative 5x and we have plus 5x are going to be gone. And then limit h approaches 0, negative 5h over h. And these h's are going to be gone, so the answer is going to be equal to negative 5, which means f prime 2 is going to be equal to also negative 5. Okay, so now I just want to talk about the notations of derivative. So there's different notations of derivative, but the most famous ones are f prime x, y prime, we call it y prime, f prime x. We have dy over dx or we have d over dx. So whenever you see this kind of expressions or notations, that means, you know, we're talking about derivative of a function. Okay, let's move on to question 2. In question 2 we have this expression. Okay, of course we have to expand this expression and distribute 6 into the parentheses, and let's see what's going to happen. Okay, so limit h approaches 0, we get 6 times x squared plus 2hx plus h squared minus 2x minus 2h plus 7 minus 6x squared plus 2x minus 7 over h. So limit h approaches 0. So let's try to distribute this 6 into the parentheses. So we get 6x squared plus 12hx and plus 6h squared minus 2x minus 2h plus 7 minus 6x squared plus 2x minus 7 and over h. So in this case, of course, there's some things that we need to cancel out. Okay, so we have this one, these two are going to be gone, and then we have these two are going to be gone, and then we have these two are going to be gone, and then what we have left is limit h approaches 0. We have 12hx plus 6h squared minus 2h and over h. So of course, as you can see, that the greatest common factor is h for this expression. So if I factor out of h, let's see what's gonna happen. 12x plus 6h and minus 2 over h. And then these two h's are going to be gone, okay, as you can see. And what I'm going to be left with, if you substitute 0, we're going to get 12x minus 2. That is the answer. And that is the derivative of this original function. Okay, so let's continue the next problems. So we have this f of x function 2x squared plus 1, and then we need to evaluate this expression. So let's do it. Question 3. Limit x approaches 0, 2x squared plus 1, and minus, if you substitute 0 into this function, you get only 1. So minus 1 over x squared. And then these positive 1 and negative 1 are going to cancel each other out, and then we're going to get limit x approaches 0, 2x squared over x squared. Okay, then these x squareds are going to be gone, and then what I'm going to be left with is only positive 2. Okay, that's question 3. How about question 4? Okay, in question 4 it says if f of x equals x cubed minus 2, which is equal to the f prime 4, which means it's asking us to find the derivative of this f of x function and evaluate it at x equals 4, which means limit x approaches, actually not x, sorry, limit h approaches 0. It has, if I apply the limit approach, we're going to get f of x plus h minus f of x over h. Okay, so I need to erase this. So if I substitute x plus h into this function for x, let's see what's going to happen. Limit h approaches 0 into this function, actually. So x plus h cubed minus 2 and minus the f of x function, which is x cubed minus 2 and over h. So let's try to simplify this a little bit. Limit h approaches 0, x plus h cubed minus 2 minus x cubed and plus 2 and over h. So in this case, this negative 2 and positive are going to be gone. We get limit h approaches 0, x plus h cubed minus x cubed over h. This is going to be the derivative of this original function using the limit approach. But it says evaluate this at x equals 4, which means you're going to replace this x by 4. So we get limit h approaches 0, 4 plus h cubed minus 4 cubed over h is going to give us the evaluated value of f prime 4. All right, so which one is the correct answer? Yes, this one. No, this one is the correct answer. Okay. All right, guys, thanks so much for watching this video. Okay, please stay tuned for the other videos. Bye.